Okay, I'm going to go ahead and do number 40. Now what they ask you to do first is find the zeros algebraically. This is actually partially factored. When we're talking, I'm going to go ahead and go through the whole process like we did the last and go against their directions. When you're going through the assignment, it does say use a graphing utility to graph, but I'm going to go ahead and show you how to do this another way. If I had multiplied this all out, I would ultimately have to distribute and have a 1/4 x to the 5th and then other terms. Remember that these other terms are just going to be of lower degree and are not going to affect the shape. Okay, this one's obviously an easy one. Minus 9, specifically minus 9 fourths x cubed. Okay, now when it asks for the zeros, okay, which is what A is algebraically, I would want to make sure this is factored completely. Well, the 1/4 x cubed is your greatest common factor, and then the x squared minus 9 is a quadratic that breaks into x minus 3 and x plus 3. If I set each of these equal to 0, I know 1/4 x cubed equals 0 will actually yield, multiply both sides by 4, I'll get 0, take the cube root of both sides, and I get x equals 0 multiplicity of 3 because of the x cubed. Use 3 of the 5 total factors. I get x equal 3 multiplicity of 1 for this next term. And I get x equal negative 3 multiplicity of 1 for the third term. If you add up the multiplicities, I'll have a multiplicity of 5, and if I look at my highest degree, I have an x to the 5th as my highest degree with a leading coefficient of 1/4. So my degree is 5. Didn't ask for this in the assignment, but just trying to reinforce. My leading coefficient is a positive 1/4. My end behavior, therefore, would be a positive x to the 5th curve is going to look like a positive x cubed curve. Is going to be down here at the bottom left and end up at the top right. So if I want to do a quick sketch of this, I would find 0, 3, and negative 3 as my x-intercepts. It's going to come here from the bottom. It's multiplicity 1 at negative 3. So I'm going to just cut through with no hesitation. At 0, it's multiplicity 3, so it's going to cut through, but it's going to hesitate a little bit. Okay, look, kind of like an x cubed right there. And then it's going to come back up and end up at the top, cut through because of multiplicity 1 again. That should be your basic sketch, what you see on your calculator. Okay, my next one, I'm just going to do one of the problems out of the assignment just to give you a feel for what they're looking for with the directions. So it says find a polynomial function with the given zeros, multiplicity, and degree. There are many correct answers. So 75 asks for a 0 of negative 2 multiplicity 2. So if I called this f of x, a degree of a 0 of negative 2 multiplicity of 2 means that x plus 2 could have been a factor with a multiplicity of 2. Now keep in mind it does say there are several correct answers. So here's another example. I could have had 3x plus 6 with a factor of 2 for the multiplicity out front. That would still give me negative 2 multiplicity 2 as the same result. So that's the reason they're saying there are multiple values. Okay. For the second part, we have a 0 of negative 1, so that would be x plus 1 as a factor. 0 of negative 1, and it's multiplicity of 1. Okay, so that would be to the first power. So technically this would be an answer just as it is. I'm not sure what the back of the book is going to say, but this is appropriate just like that. Now, other possibilities. I could stick a negative 2 as a leading coefficient out front. That's going to flip the curve over, stretch it a little bit, but it would still meet these requirements. I could stick a 1/2 out there. It would be the same basic idea. So there are a lot of options for this section. Okay, the next one I'm going to do from the assignment is number 81. Sketch a polynomial with a given condition. Sketch a graph that function that satisfies given conditions. If not possible, explain. There are many correct answers. So similar to the last one, we've got some options. This is going to be a third-degree polynomial with 2 real zeros and a negative leading coefficient. Okay, so in order to get, I'm going to actually write one just to give you an example. It's got to have 2 real zeros. So I'm just going to say, let's suppose the zeros are x equal 2 and x equal negative 1. Okay, it's got to have a negative leading coefficient. So there's going to be a multiplier out front that's going to be negative. It could be negative 2, negative 1, negative 1/2, whatever. Okay, third degree polynomial. Now, if these are each multiplicity 1, since those are the only zeros, then that would only give me a second degree polynomial because 1 plus 1 is 2. So I would need to change one of these to multiplicity of 2 in order to make that happen. So if I actually wrote that out as a function, that'd be x minus 2 to the first and x plus 1 to the second. That would be, if I multiply all that out, that would be a positive x the first plus some other terms times this. That'd be x to the first and then x to the second plus some other terms. So ultimately that would be a something x cubed. So plus some other terms, or a something x cubed. That has a positive leading coefficient. I need a negative leading coefficient. So I'm going to stick a number like negative 2 out front. Ultimately, when I multiply those, that'd be negative 2 times an x to the first term times an x to the second term. That'd be a negative 2 x the first times x the second, or a negative 2x cubed, plus a bunch of other terms, x squared, x the first, etc. So I'm going to leave it in factor form, but I'm going to do a quick sketch of this. Let's see if I can minimize this a little bit. And my sketch for this particular one would have a 0 of 2, a 0 of negative 1. It's got to be a negative x cubed. With in my case, I have a multiplicity of 2, so I'm going to, negative x cubed is going to come in here and here for the end behavior. A multiplicity of 2 is going to bounce, and then a multiplicity of 1 is going to cut through, look something like that when we're done. Now, is this the only one? No, there are technically probably an infinite number of possibilities there. Okay, this is one sample.